So what we are going to visit today is the first step of building up our institute. So we are establishing here the first production area, which we call the FFB prefab. In the FFB prefab, we can find 18 different production steps, all from European machine suppliers and not interconnected. So we can basically transfer everything. We have one public line where we can really work from 2 different mixing methods all the way to cell finalization for pouch cells, and prismatic cells are over here, and then the finalization is on the outside. What is innovative about the concept is really that we have one line making cells and we have empty rooms. So we are not renting the rooms out to students for a lot of money, but we are renting those out to companies.
Okay.
So basically a company can come in, put their machine in this room, and then at any given point of the production chain, we can take out semi-products, put them inside the room. The company can do whatever it wants with them. They can put ketchup on it, mayonnaise, or fry it, give it back to us. We finish the cell build, and at the end, they have a finished cell. With ketchup, mayonnaise, and fries, it's not working, but if you add surface layer coating, homogenization, or mechanical pre-treatment of the electrodes to it, it's a viable business model.
Okay.
And with this short intro, I think we should go inside, that you see everything. And okay, so this is our material chamber. Basically, from here we are entering now the clean and dry room. Once everything is set up and runs, here only material, the slurry wagon we saw before, and all the other stuffs are going to be transported, and the personnel, the workers and scientists are coming from the other side.
Okay.
Today we can walk through here and use the big entrance. So starting from here, we are in the clean and dry room, and here already you can see part of our innovative concept. In this middle hallway, you can always transport things inside the clean and dry room, and you can bring it from the production line, which is on the left-hand side, always to our innovation modules.
Okay.
And in the innovation modules, a company or a research partner can put in their machines, they can tailor whatever they need, they can ask us, bring us powder, bring us electrolyte, bring us some copper foil, or bring us electrodes, or bring us stacks. We can all transport it without having to contaminate it with air or bring it outside of the factory, but just deliver it. They can do their process, their technology, keep everything in this room, which has also a IT connection to the outside, give it back to us. We finish the cell build. At the end, they did not have to invest in mixing, finishing, electrolyte filling or anything, but just really in their process at the line. So at the moment we are at a different stage of site acceptance tests. You will see some of the machines running, some of them in the preparation for running. So for today it's okay this way, but normally we would have to go suit up in a bunny suit, cover mouth, nose and so on. And then we are also working on how we correlate worker time versus dryness. Because this is also an important factor. We don't want to risk the health of our people, so we really want to see we can go up to -60. At what dryness level, how long can you work in the clean and dry room?
Okay, gotcha.
So we have here the coating device. The coating device is 10 meters long and starts in the other room. So you avoid contamination from the liquid to the dry electrode. The electrode ends up here. You can unwind here and have a almost dry electrode here with the normal length of 10 meters, drying device for 10 meters of speed. So 10 meters per minute equals 10 meters of drying.
Yeah.
We can go up to 60 centimeters, so you see the markings here.
Yeah.
We have also all the slots here. So I think active coating with, it's a little bit above 60, foil with a little bit above 60, something we will figure out at the end, because electrode overlap at the edges. We are also working actively with a startup to implement their coating technology here. So we are waiting for some funding, project alignments coming along, but it's also then envisioned or planned to really adapt new technologies into the machine, and this is also what makes us different. We are not setting up the coater to have it run 24/7. We set it up, we want to work, but then our next step is already how can we make it better, can we bring innovative European startups, machine suppliers into this ecosystem to really bring in their parts to this device.
Okay, cool.
Here you see another German machine from a company relatively close by, calendaring. So we get the electrodes and then we go further, bring it in, and then press it down, calendar it to get the right density. You see, we are not fully operational with this device yet. We are already coating. Today we had the NMC coating run.
Okay.
For the calendaring, I think we will be operational in a few weeks. It's already here. And the other parts further down, slitting, vacuum oven is already working and operational. For example, here you see a starting point. You see the measurement device is on. And what we do is we always try to implement a lot of sensors, a lot of software. We can actually, now you can't see it because it's behind the crate, but we are collecting everything we cut. We take pictures of everything we cut, also to help us to train our quality models, quality systems, and so on. Mm-hmm. So this machine actually will be most likely way too fast for the amounts we produce, but we want to be close to industrial speed. So then we will turn it off only for a few hours, but then we have already a feeling about how our electrode, our products, the products of our customers are behaving at the speed which is really close to industrial level.
You're using a knife, right?
Yeah.
What was the decision for knife versus laser?
I mean, for a very efficient gigafactory at the moment, if you see it now, a knife is a good choice, depending on the size and format. I think for very efficient, smaller scale cell production, where you have maybe some angles, maybe some harder corners around the welding tab, there laser could be a possibility. But as you see, we are going to single sheet and C folding stacking. There the knife really has some benefit. And we will get the laser cutting module later together with Fraunhofer partners. We're using
ALT or?
Exactly. We're using ALT, these technologies from Aachen, and bring that in for smaller batches, for the large batches. We're thinking knife is still a very good option. Here already see our drying concept. So basically once the electrode is coming out, pressed, cut, we can either bring the mother or the daughter cores, so either cut or uncut, here into our vacuum drying ovens, where we remove the rest of the humidity. The vacuum drying ovens are fairly large, and what our vision is that we put in 6 coils, and then at the next day, the worker on the other side of the oven can open the back door and bring it out. And now we have to walk around because it's not good to go through the vacuum oven. So here I'm really curious what we will find now. I haven't been here in the last 2 weeks, and we are very busy setting up things. And you can already see the room is pretty full. And now we just have to wait for our antechamber to close that we can enter. Basically, this is the back side of the oven. We saw from the other side. Here you can see one of the cards with the electrode on top. This one was cut here on this side. You still have some current coil, still some wrinkles here and there. But this we already use to cut our sheets. Here, cathode, anode sheet. And here we already see some products from the stacker we are utilizing, all wrapped in separators. And then we can all the way go up to this size, so up to 60 centimeters long. It's basically a little bit longer than the cell you can buy from LG Energy Solutions, but we also focus on smaller cells which are more in the range of 30 centimeters width. And this all happens here in this room. So basically in this 6 machines, you can put in your electrode sheets, you can put in your pouch foil, and at the end you end up with a very nice cell. And what we do, we utilize the stacks here also for manufacturing of prismatic cells. You can envision that if you use a higher number of electrodes on top of each other, you can also easily fit the stack in a prismatic cell, and this is what we are doing in the room next door. Here you have the similar machine for the cathode side. Why do we use 2 different machines? First of all, it allows us a little bit throughput, and you don't have to talk about cross-contamination, and also you can implement maybe different technologies to really see what is going on and do things. Here we have the blister forming. sometimes a little bit an underestimated step. Here you really need to make the pouch cell housings for your foil. Basically what you see here is the machine where we do the stack building. In the stack building you can utilize different technologies. You can use single sheet stacking where you stack each sheet over each other, or you can do a C folding where you have a separator in an endless line and you slip in anode and cathode from the side. In our machine we can do basically both. That gives us the possibility to compare those technologies, and we can also utilize our full flexibility scale. What does that mean is the machine can build cells up to 60 centimeters long, up to 20 centimeters high, but it does not necessarily need to. We can do with the same control, the same quality, also smaller cells, and our customers have to kind of purchase or build the tooling inlays for the machines, and then we can manufacture their size, their format for them on this machine with the same quality as our own cell formats and our own products. And here you can see a little defect. This can happen, and this is typically during ramp up. But what we are doing is we are really controlling the ramp up. We are taking images on the detailed protocol of all the defects, of all the errors, not errors, of all the tries we do. And then we try to use machine learning and other tools to really get a feeling about what the reason for this failure is, and also then to help our customers to avoid these failures by setting up a database, setting up training test protocols. And so it's not only that we want to have the perfect quality, but we really want to document the way how to get there. So Simon, now we are entering one of the secret recipes of our business model.
Okay.
The empty rooms. Mm-hmm. As I told you, we are not renting those out to live in, but we're renting those out to our partners. Okay. So basically in this room, what we will find once we enter is you will have full access to gases, full access to electricity, full access to all chemicals, and your own IT infrastructure.
While being in a dry room or also clean room?
By being in a clean and dry room, and you can even control the temperature in a way you want. Do you need -20? Do you need -40? Do you need -60? We can do that here. You pay the electricity bill anyway. We've built in some IT infrastructure. We've built in different connections where you can have exhaust vents. We have gas outlets for your gas. And you can put in anything you want. We have portable benches, chemical wet benches to put in here, storage boxes, whatever. Basically, the biggest problem is how to fit through the door. But even for that, we have a solution. If you look here, sometimes the cables are going a bit on top. So you can basically take out the wall, bring something in, and put it back in. And then this room is yours to do research, to develop something, and to be really close to our line so that we can support you, give you the products you need, and then test what you have done in our large cells on the outside. So now, since we started in the middle with our big room, we are now going back to the mixing area, where I want to show you how the powders are made into our slurry and how we do the processing of new materials inside the clean and dry room. Now we are going through our storage area to the mixing area. What you see here is basically our short-term supply. The short-term supply should range around 2 weeks, and then we have partners where we store more materials. So we basically buy materials in crates, barrels, boxes, whatever you need, and then we store some of them here, which we'll need in the near future, and we have a partner very close by where we store more and use it then later. So here you see we have a different setup on the ceiling. This is not a dry room anymore. We still want to keep it clean, but it's the typical mixing area. So what you see here are 3 different rooms. One room is dedicated to really aqueous coatings, very high mass loadings, very high coatings, and then we have batch mixing and continuous mixing and the cleaning station. So first we look at the batch mixing. So you have your glove boxes to prepare your powders. Here you have your batch mixing, and then you have your typical crates where you transport the slurry over into the clean and dry room to really see, to really make the electrodes and do it there. Basically, this is the continuous mixing device. You have your powder feed in, and here you have the screws, which normally go inside here. If you look from this side, you see the two holes where they normally entering. And what we did with these instruments, we added several circuits where we can flow different liquids for different temperatures. We have different sensors. We have also one project where we do a kind of in situ investigation in the flow. That means we're taking continuously samples out of it, mix it, and have an analyzed system here, also together with other partners to really see how the process evolves over time. One of the problems of continuous processes is the quality control. You have never a certain point of time where you know how the quality of your slurry is and how it behaves. And with this additional quality checkups and instruments, we want to ensure that once we scale this up, we can also have a better quality overall and during the whole production process. For us, it's very simple because we buy the equipment from either our industry funds or from our public funds. We can always use them and adjust them. So here also we have material which is a base system by a Swiss company, but we can add our own things. We can add other equipment. We can add pre-mixing from German manufacturers. We can test quality control from maybe a Dutch manufacturer and so on. So we are very open to really work on the machines with our partners, and I think this is quite astonishing because normally once you have a running setup, you don't want to change too much. For us, changing is good. We want to bring new technologies into the process, and that's what basically our daily business will be in a few weeks or months. Here is our coater. As I said, 10 meter per minute, 10 meter convection drying zone. We will also adjust the drying to different technologies. The small coater we have outside is already equipped with laser and near-field IR, so we're also envisioning to do this. And here we can do slot die, plate coating, and we are working with different companies to implement also new technologies, bringing it to a different kind of electrode. And one thing, since we are in Europe and we have good and reliable environmental regulations, we have also connected the whole coater to an NMP recovery system. So basically you see the pipes going up, and a little bit simplified, it's a kind of condensation system so that almost all molecules of NMP which are processed here stay in the loop and then are transported offsite to be regenerated so that they can use it again and you don't evaporate any NMP into the air. It's a little bit simplified the process, but it should give you a hint how it works. So we are now on the outside of the production area again, and what we call the south wing. In the south wing, our innovation partners have their labs. So we are really focused on scaling up, building size, bringing technologies to life, but we're working with the research partners here and in Münster, in Aachen, but also, for example, with Professor Janek from the University of Gießen. And they have here their own labs. They can really produce research, produce products that we can use them then later on the line to scale them up. And this is really a big part of the whole value chain for us, because only collaboration between research, industry, and we as transfer device can really help us to accelerate the development in Europe. The Forschungszentrum Jülich is one of our partners with a lab here. So we're really trying to bring the best expertise from North Rhine-Westphalia, but also from the rest of Germany here, bringing the technology together.